Okay, now we're going to do everything again, but with a new function. We have f of x is the cube root of x, and we want to figure out what its critical numbers are, its relative extrema, and where it's increasing and decreasing. So we're going to first take the derivative and set it equal to 0. Figure out where the derivative is either 0 or undefined. So the derivative of x cubed, well, this is the same exact thing as x to the 1/3. So we might need to take a second and rewrite this. And so our derivative ends up being 1/3 x to the negative 2/3. And we're going to try to set this equal to 0, which we can't do until we get the negative exponent where it belongs. So I have 1/3, but negative exponents belong in the denominator. So this is 1/3, and then that x to the 2/3 should be in the denominator. What also might help me is putting this back as a root. So I'm going to do that as well. So some algebra here. So 3, and I have x to the 2/3. So my power is 2, and my root is 3. And that equals 0. Well, as you can see, I can't actually make this derivative 0, because the only thing that's going to make this 0 is if the denominator is actually 0. So I'm making the derivative undefined, which is totally fine. It's a new type of critical number. So I want 3 times something to be 0. This something on the inside must have been 0. So this is only going to be true if x is 0, right? 3 times something, the third root of x squared, that x value must have been 0. This makes f prime undefined because we're going to make the denominator 0 this time. So our f prime isn't going to actually be 0, it's going to be undefined. We're going to divide by 0. So our second step is to use this critical number and make a sign chart. So our one and only critical number, the only thing that makes the derivative 0 or undefined, and in this case it makes it undefined, is when x is 0. So we're going to label that critical number in there. Makes f prime undefined. This is the only x value that will be in our answer boxes down there, not the random critical numbers or test values, sorry. We're going to plug in to the left and right of our critical number. So maybe to the left, I'll choose -1. And I'm going to plug into 1/3. And I have the third root of -1 squared. Well, -1 squared is going to be positive. So the third root of +1 is positive. And then I have 1/3 times that positive. So this is going to definitely be positive. And you can plug into your calculator if you don't want to try to do these roots in your head. So I'm increasing before 0. After 0, I'm going to plug in a +1 as my test value. You could choose any number you want. So I'm going to have 1/3 times the third root of 1 squared. Well, 1 squared is 1. Third root of 1 is also 1. Times 3 is just 3. So I have a positive 1/3 there too. And again, the value doesn't matter, just the sign of it. So I'm going from increasing to increasing. No sign change on my sign chart means no relative extrema. So there are none for the relative max points, none for the relative midpoints. I do have a critical number at x equals 0. That makes the derivative undefined. And then I'm increasing everywhere except for at x is 0. So I'm increasing before 0. Union, I'm increasing after 0. Like a U. So 0 to infinity. And the reason why I don't just simply say negative infinity to positive infinity is because the derivative isn't actually positive at 0. It's undefined. So before and after that, I will have a positive derivative, which means I'm increasing, and there's no intervals where I'll be decreasing. So just write none.